Escape speed. When a body is projected vertically upward from the surface of Earth with a certain speed, its motion is opposed by gravitational pull and resistance of Earth's atmosphere. Due to it, the body rises up to a certain height and then falls back to the Earth. As the speed of projection is increased, the body attains a greater height before falling. Finally, a stage reaches when the speed is so large that it just crosses the gravitational field and will never return back to Earth on its own. The body is said to have escaped. The minimum speed of projection to achieve this stage is called escape speed. So to understand escape speed, we'll just define now here that escape speed on Earth or any other planet is defined as the minimum speed with which a body has to be projected vertical upward from the surface of Earth or any other planet so that it just crosses the gravitational field of Earth or of that planet and never return on its own. That means the minimum speed, कम से कम स्पीड जिसमें कि कोई भी बॉडी किसी भी प्लैनेट के ग्रेविटेशनल फील्ड को क्रॉस कर जाए, दैट मिनिमम स्पीड इज कॉल्ड escape speed. Okay, so we'll derive the formula for the escape speed of Earth. First of all, we'll see, let VE, that is the velocity or escape velocity or escape speed, be the speed given to a body of mass m, small m here. This is the body. Suppose here you can see this is the radius of Earth here, and the mass of Earth is m, and from the surface of Earth a body is thrown like this way. The mass of the body is m here, and the body is thrown with the velocity VE. This is the minimum velocity, and because of this velocity the body will cross the gravitational field of Earth and will never return on the surface of Earth. So in this case we see that means we are providing the kinetic energy to the body, and when it reaches to some height it will gain the potential energy. So what we will see at infinity means the body just goes out of the gravitational field of Earth, that is at infinity, and then total energy of body at infinity is zero. Already we have learned that the total energy, potential energy, we have seen that the total energy of the body at infinity is zero here. So now V is called escape speed, and using the law of conservation of mechanical energy for the body. If we are using the law of conservation of mechanical energy, that means the sum of the potential energy and the kinetic energy, that must be equal to means that must be same at each and every point of the journey, and because at the infinity it is zero, so that must be zero. That means the potential energy plus kinetic energy must be zero at each and every point like this. Okay, so potential energy means whatever initial energy would be there, that will be final energy according to the law of conservation of mechanical energy. So we'll see that the sum of potential energy and the kinetic energy of the body at the surface of Earth, that must be equal to the total energy at infinity. So that is the potential energy is minus gmm upon r on the surface of Earth, that we have derived the formula already, and we know that the kinetic energy is given by half mve square. Here ve is the minimum velocity by which the object is thrown so that it will not return to the Earth's surface again. So that is, so the sum of the potential energy and kinetic energy, that will be equal to zero, because this is the right hand side is the total mechanical energy on the surface of Earth, and the left hand side, the left hand side is the total mechanical energy on the surface of Earth, this one is, and here the right hand side it is the total energy at infinity, and which is equal to 0. Okay, so just applying this formula, we'll see here, that is VE square means VE square is equal to 2gm upon r. Okay, that is what here you can see that this is half mv square. So ve square, if we'll write, we'll just transfer the 2g mm upon r, and would be cancelled. Okay, so or either I will write here, better it will means you can understand the formula, which is gmm upon r plus half mve square equal to 0. So here half mv square must be equal to gmm upon r. This m would be cancelled, so ve square is equal to this 2 will go that side, so 2gm upon r. Now ve, if we'll take, this is root of 2gm upon r. Okay, so here the formula came, that is the escape velocity ve is equal to root 2gm upon r, and since we know that the acceleration due to gravity g is equal to gm upon r square. Okay, so that means gm we can write as gr square. So here in this formula, in place of gm, we will write here gr square. So ve is equal to 2gr square upon r would be cancelled, then v is equal to 2gr. This is root of 2gr. Okay, so the escape speed is equal to root of 2gr. It can be for the earth or any other planet. That means here in case of earth, this is the root of 2g, that is acceleration due to gravity, and r is the radius of the earth. Okay, and some important point related to the escape speed is that the value of escape speed of body does not depend upon the mass of the body and its angle of projection from the surface of earth or the planets. That means whatever body is thrown, जो भी body थ्रो की जाती है फ्रॉम द सरफेस ऑफ अर्थ, तो उसके मास पर डिपेंड नहीं करता है. दैट मीन्स द escape speed is never depending on the mass of the body, that body which we are throwing. Okay, and its angle of projection also means it is not depending on the angle of projection also. Here in the formula you can see that these quantities are not present. Okay, so the escape velocity or escape speed is independent of the mass of the body thrown and the angle of projection. Second point, ve, that is the escape speed, depends upon the mass and radius of the planet. Once again, listen carefully, that is the mass and the radius of the planet. It is depending on the mass and the radius of the planet, but it's not depend on the mass of the body which is thrown. Okay, so here of the planet and from the surface of which the body is to be projected. Now clearly the value of escape speed of a body will be different for the different planets, because for different planets mass would be different, the radius would be different, so it will depend on that factor. Okay, so that's why the escape velocity for each and other means any other planets would be different. Okay, now you will see that as we have seen in this formula, that is the escape speed is directly proportional to the mass of the planet, under root mass of the planet, and mass is depending on the density, because for any spherical body we know that the mass is equal to 4/3 pi r cube rho. Okay, so mass can be written as you can see in this way, like the speed we are writing here, that is v equal to 2gm upon r. Now the mass we can write as 4/3 pi r cube rho. So if we'll just put the value of this, that is 4/3 pi r cube rho upon r, whatever it is, so you'll find this is the density. So v is directly proportional to root of the density, that we are considering the density of the planet or the earth is uniform everywhere. So in such situation you will find that the escape velocity or escape speed is directly proportional to root of the density of the planet. So the escape speed on the surface of planet of high density is more than the surface of planet of low density. Now we'll see the escape speed for Earth. What will be the value of that? The escape speed, that is we know that acceleration due to gravity, generally we are taking g, that is equal to 9.8 meter per second square for the Earth's surface, and r, the radius of Earth, is 6.4 into 10 to the power 6 meter. So the escape speed, if we are just putting the value of this 2gr, so we'll get 11.2 into 10 to the power 3 meter per second. We can change this into the kilometer, that is 11.2 kilometer per second. So this is the